All right, guys, let's go ahead and get started on section 1, topic number 7, which is adding and subtracting with radicals and rational exponents. Obviously, those are the same thing. You're just going from one form to the other. So let's look at number 1. Number 1 is square root of 7 plus square root of 3 plus the square root of 98 minus the square root of 18. And right now we can't add or subtract any of these because none of them have the same number underneath the radicals, but we can see if we can simplify any of these radicals. So number 7 can't be simplified, neither can 3, but 98. So we want to think about what perfect square goes into 98, and that would be 49. And 49 times 2 is going to give us that 98. So then we want to take the square root of each piece. So we still have square root of 7, square root of 3. The square root of 9 is 7 times the square root of 2 minus an 18. We can also break up. The biggest perfect square that goes into 18 is 9, and 9 times 2 is what gives us that 18. So the square root of 9 is 3 times the square root of 2. So now that we've simplified as much as we can, we want to combine like terms. So the like terms here would be 7 square root of 2 minus the 3 square root of 2. So the first two terms are going to stay the same, the square root of 7 and the square root of 3. But then we want to just subtract those coefficients. So 7 minus 3 would be 4 square root of 2. And I'm not going to do the second one in that problem because it's pretty similar. Again, you'll just simplify as much as you can before you start to combine those like terms. Number 2 is pretty similar, except they're written as rational exponents. So the first thing I would do is rewrite these problems as radicals. So the first one, 8 to the 1/2 is the same thing as the square root of 8. 16 to the 1/4 is the same thing as the fourth root of 16 minus the square root of 12 plus the fourth root of 81. And I know it's the fourth root because it's raised to that 1/4 power. And then we can simplify each of these pieces. So square root of 8 we can break up into 4 times 2. The fourth root of 16 is actually a whole number. It's 2 because 2 times 2 times 2 times 2 is 16. And then the minus the square root of 12. 12 we can break up into 4 times 3. And then the fourth root of 81 is also a whole number because 3 times 3 times 3 times 3 would give us 81. So we want to then simplify here. So square root of 4 would give me 2 times the square root of 2 plus that 2 minus the square root of 4 is 2 times the square root of 3 plus 3. And then the only like terms we can combine is the plus 2 and plus 3 because the square root of 2 and the square root of 3 aren't the same number under the radical. So we're going to have 2 times the square root of 2 plus 5 minus 2 times the square root of 3. Okay, and then number 4, we want to know which of these is equivalent to 4 times the square root of 3. So it is a select all that applies. So remember that means that there's going to be at least 2 answers and not all of them can be correct. So the first one is 4 to the 1/3 and 3 to the 1/3. So that 1/3 means that it's the third root of those numbers. So the third root of 4 plus the third root of 3 is not going to be the same as 4 square root of 3. So we're going to go ahead and mark that one off. The second one, this 27 to the 1/2 and 3 to the 1/2. So that means the square root of 27 plus the square root of 3. So right now it doesn't look like it could be the same, but let's try and simplify. That 27 can simplify to the perfect square of 9 times 3. And then if we take the square root of each of those, the square root of 9 is 3 times the square root of 3 plus this other square root of 3. And these are like terms. They both have a square root of 3, so we want to add them together. Technically, this has a 1 out in front of it, so 3 plus 1 would give us 4 times the square root of 3. So that first one, it is the same, or the second one, excuse me. The third one, the square root of 32, we could simplify that into 16 times 2, and when we take those square roots, that's going to give me 4 times the square root of 2, which is not the same. The square root of 48, sorry, I'm all over the place here. The biggest perfect square that I can think of that goes into 48 is 16 times 3. And then the square root of 16 is 4 times the square root of 3, which is the same. So the fourth one is correct. 2 times the square root of 12. 12 can be simplified into 4 and 3. So then here I have 2 times the square root of 3, which isn't the same, but remember I still need to multiply it by that 2 to give me 4 times the square root of 3. So that actually does end up being the exact same. And by process of elimination, I'm going to go ahead and tell you that the 2 square root of 18 is not going to be right, just because we know that we already had 2 times the square root of 12, which was correct. And then the last one, 27 plus the square root of 3, is actually the exact same thing as this one. It's just written in radical form. So we're going to go ahead and say that that last one is also correct. And then the last problem I wanted to do is number 6. I'm actually just going to do one of these, and then you can work on the rest or ask me on Remind if you want me to do another one. So I'm going to do the rectangle on the right. So it says, find the perimeter. Remember, perimeter is adding up all the sides. So obviously for the triangle, you'd add up all the sides. For the square, you'd add up all the sides. So right now, this rectangle has one side that is 1/4 times the square root of 100. And remember, we have 2 of those. Plus this. So 2 square root of 48 plus 4 square root of 75. We actually need another one of those. Let me see if I can fit it on my thing. Plus 2 square root of 48 plus 4 square root of 75. So the first thing I'm going to go ahead and do is combine like terms. So I can combine these and these. 1/4 and 1/4 would give me 1/2. And actually the square root of 100 simplifies to just 10. Plus 2 square roots of 48 plus 2 square roots of 48 would be 4 times the square root of 48. Plus 4 square root of 75 plus 4 square root of 75 would be 8 times the square root of 75. So that's so far. And then we want to do the best we can to simplify this. So 1/2 times 10 would just give me 5. And then I'm going to make my screen lower for this. So we want to simplify the square root of 48. And that can simplify into 16 times 3. So that would be 4 times the square root of 3. And that would be our next one. But remember, we got to multiply it by that 4. So that would actually be 16 times the square root of 3. And the last thing we need to simplify is the square root of 75, which simplifies into 25 times 3. And then if we take the square root of each of those, we get 5 times the square root of 3. But remember that we got to multiply 5 times that 8. So that would actually give me 40 times the square root of 3. And then the very last thing we can do is add those coefficients that go with the square root of 3. So we have 5 plus 16 times plus 40 is 56 times the square root of 3. Okay, that's all I'm going to do out of section 1, topic 7. But if you have any other questions, please message me on Remind or send me an email. Bye, guys.